and after discussing a lot about testing, I'm now saying some words about how we test it in reality, so in real productive world. And as an example, I will show you how the workflow has improved by applying the CAPE-OPEN connection to our systems on the example of an wash system. It's a rather short one, but maybe we can have some discussions after that. So first of all, I will show you how it was, the workflow, then how it is now with the CAPE-OPEN application, and then I will just show you two examples, and then I have some points about features that would help us in the daily work that we wish to be implemented. And then, of course, questions, comments, whatever. So first of all, we as Linde Engineering, we built or we design first and then build whole complexes. So we aim for that we have a so-called holistic plant simulation. So all the different process units are simulated in one big simulation. With this, we mainly use the UniSim simulator, and the basis, that's the Linde GPS property data system. With the process simulation, we go via a transfer file into our databases, and from there we then start the engineering. So, like example, equipment design. That's what Stefan discussed. Then, of course, also the piping design, pressure loss calculations, plant safety itself, as well as plant control and instrumentation. That's how it should be. The reality is something different because, as an example, we have we are using here also any wash systems, and we as Linde do not have the kinetics of the reaction. That's why we need to have in the past we had a standalone simulation for the A9 systems. There we used either the BASF OAS Connect software, or if it is a non-activated system, we are also using the ProTreat. The problem is that those systems were not exchanging, so we had to transfer the input and output data manually, and also doing all the iterations, especially if there were changes in the feed gases, so we need to change the system. And all these manual input data and the change of the simulation environment, it was very time consuming. It was always an issue, okay, did we type in all numbers correctly, or is there a mistake? And of course we have always the big question mark about the different property data we're using. But now we can just implement the A9 unit into the total simulation itself, and of course all the problems are solved. I think that was the aim for you guys to start to work, and from my practical point of view, really many of these issues they have been solved. So now that's just a small flow sheet, or just an extract of it. For example, that's here just a wash column that we simulate in UniSim just as a splitter because we do not have the kinetics about it. And what we do, which is here, so we are doing the design of the wash unit itself still within the unit, so within, example, the OS Connect or the project itself. But what we do is we are using the input and output ports. For example, the feed gas that's coming or that's calculated from the other unit is directly transferred to the CAPE-OPEN unit. Then the system calculates and gives back the treated gas. That's something that's really saving us time. As another example, because we are just not just generating data regarding input and output, but we also need a lot of internal streams, because all the process streams are transferred into our databases. So we need a lot of temperatures, flow rates, also heat flows and so. And these are not accessible by the ports. So these we need to manage via the variables. And there we created a kind of a workaround that we import the results from the CAPE-OPEN unit to the UniSim spreadsheet. And from there we export it to the UniSim streams. That's shown here that, for example, in the example of the absorber, we imported the temperature of the bottom of the column to the stream itself. But here it's very clear that here we have the problem of the different property data. Because just exporting the temperature and then using our property data will, for example, result in that vapor phase is suddenly a two-phase flow, or the transferred heat from a heat exchanger that has been calculated in the CAPE-OPEN unit has a different duty or a different minimum approach or temperature difference than the same unit that's simulated in UniSim. And that's still a problem. Yeah, and for just what we see is that from the daily workflow, we have one problem, or one thing I want to mention is that right now not all process variables we see in the standalone simulation. So not all of these variables we can export to UniSim. So for us it's not really clear why there's a difference. Because I have a license for the standalone software, why can I not use all of it also in the CAPE-OPEN application? And something that's regarding UniSim is that the importing of the spreadsheet of the variables via spreadsheets, and that one has a long response time, and that's sometimes really hard to work with it. And then the whole complex of where to save the data of the simulation files of the base simulation. That's also a little bit complicated because you have the UniSim file, and in the background or in a separate folder you have all the files of the embedded application. And of course, the most pain for us, that's the need or the wish for equalization of the thermodynamic properties. That would be a really big step in our everyday life.